All right. So welcome to Science Academy Tea Time. It is April 16th, 2026, and we are ecstatic to have as our guest my good friend Michael Desjardins, Ph.D. He's a spatial epidemiologist at Johns Hopkins University, where he focuses primarily on tracking disease spread, right? And mostly, was it 70% research, 30% teaching, something like that?
Yeah, well, we'll get into the
Yeah.
specifics, but
Yeah, a
yeah,
lot of research. But anyway, PhD from UNC Chapel Hill, right?
Charlotte
Charlotte. And Waterbury native that you guys hopefully can all relate to.
looks good. All right, yeah, thanks everyone. I really enjoy talking to students, whether they're high schoolers, undergrads, grad students, so on and so forth. So today, or tonight actually, it is 8 p.m. We'll go over kind of what is epidemiology and then my kind of specialization, spatial epidemiology. How I got here from Waterbury, right? I was born and raised in Waterbury, and I'll go over kind of my background where I was educated in Waterbury, and then um, find out how I got into science and how I got a nice opportunity at Hopkins to really start my career, and really happy here. And this is going to be pretty brief, but hopefully somewhat comprehensive, and then we'll get into hopefully about a 30-minute Q&A. I want to have an opportunity to talk to all of you about, what goes into science and research and getting grants, and talk about a little bit what Hopkins does that's different than other universities in terms of our funding model and how we pay our salary. Um, so yeah, like I said, I grew up in Waterbury. I went to Saints Peter and Paul Grammar School, which is now closed, which I think Dr. C went to as well. Um, I went there preschool to grade 8. And, I really fell in love with science and geography then, without talking too much about my childhood. I really enjoyed science classes, the science fair. I made my own telegraph system and forget what else I did in 8th grade. But yeah, just a really nice time. We had really good science teachers and loved chemistry. And my 8th grade teacher, Mr. Gambardella, I still credit him with getting me into the field of geography and spatial science. I did a profile for our injury center last week and really credit him with getting me started in interest in this area. And I'll have to send him that feature just to, tell him how important he was in my early career.
Who?
Um,
Who is it?
Mr. Gambardella, James
Oh,
Gambardella.
yeah.
Yeah,
Okay, yeah.
yeah.
There's a bunch of students in this group had him multiple times. I had him twice. Yeah.
Oh, amazing. Yeah, really cool dude. I think he's retired now, but loves playing the bass guitar too. So um but as a kid, I was more interested in sports, so I loved playing soccer and baseball and basketball, but mainly focused on soccer and baseball, and went to Sacred Heart. Um, a lot of my friends now are from Holy Cross. Sacred Heart's obviously closed as well. I played on varsity soccer, JV baseball. Um, and again, my favorite classes were chemistry, physics, world geography. I had really good science teachers at Sacred Heart. Um, but again, I was more focused on sports and girls and all that stuff. I was more of a jock, I think. I was probably an average student at the time, but excelled in the science classes. And I wanted to play soccer in college, so I got recruited to play for a few D3 schools. But uh, I forget what happened with like preseason. I was going through like girl stuff and she was pressuring me. So, that's another story. But the point is, I didn't play for the university. I'll get into where I went after that, but um, actually followed my best friend. Like 80% was because of soccer, but Adam Lawley, who also went to Holy Cross, went to Keene State as well, and we were roommates all 4 years and still best friends today.
He says he followed you there, and you say you followed him there.
He's definitely lying. He was a little upset at first that, he didn't get to grow his wings separately, but it was the best time ever. As you could see us there during graduation with our dog Marley eating the diploma with our roommate Ben. But went to Keene State College and I came in as a psych major. I wanted to be a child psychiatrist. But I took a geography class and I was really in love with it again and really got into the statistics and kind of field work behind geography and, what is it beyond just capitals and places, which I'll get into with my research and whatnot later on. But this was my first experience with research. So my junior year, I applied for an undergraduate research grant, which allowed me to apply geographic information system technology and scuba, where I went to the Turks and Caicos Islands and collected data along these different reefs of substrates, marine life, coral, sponges, to look at the vitality across space. It was for a volunteer organization like this global initiative called Reef Check International, and you um, send your data there to keep check on vitality and how the reefs are doing with all the bleaching stuff and climate change. So that was really fun. Got to mentor some high school students there, as you can see on the bottom left. Um, my first exposure to conferences, presented at a few conferences in Tampa, Florida, and Amherst, Mass. And I got my bachelor's in geography and a geographic information system certificate. Really credit my mentors at the time in biology and geography for pushing me to pursue graduate school. Um, they saw potential in me that I didn't see before, so just kind of emphasizing how important teachers are at any level. Um,
Like, could I ask a question?
yeah,
Could you explain a bit how you got into that research grant with the scuba? Like, how did you even find out about that? How did you apply for it and all that?
so I took a tropical marine biology class because I always wanted to go scuba diving, and part of that was getting certified in scuba,
Mhm.
where we, for an entire semester, 3.5 months, would study marine life, sponges. We had a tank in the class with different fish and stuff. And then we did our kind of written test for scuba at Keene. And then we flew down for 10 days, did the certification dives and hung out, learned about the culture and, how important reefs are for not only medicine and health, but obviously protecting the islands. That's how we have such amazing white sands in some places. They're like these filters that chew up all the substrate. Um, so during that time, I was like, hey, I'm really getting into my major. I could collect data with GPS and whatnot and talk to my marine biology teacher during that trip and said, hey, is there any opportunities to work with you? I know you mentioned that you go down twice a year to do this volunteer work and found out there's these opportunities at in my university or college to get some funding. I think it was like 5 or 6 grand, allowed me to pay for travel and fly down there, lodging, and pay for some supplies and whatnot, and a little bit of salary just a supplement that I didn't use. And so, I put together like a research paper and contributed to the volunteer stuff, and they had me, train some high school students how to snorkel and identify fish. I'm an eco diver, so that means I could, well, I lost a lot of that, but at the time I could, point out fish and different corals and whatnot and explain what it was. So that was really useful, just seeing kind of the direct impact that you have on students that you're mentoring and all the cool places that you could travel. If you want to get into science. I've worked with some undergrads too. I was at a conference, an injury prevention conference in Rhode Island over the weekend, and there's this high schooler presenting actually a poster, and he won an award. So, it's never too early to get started. We could talk more about that later, but so that gave me kind of a lot of motivation and I guess a good application package for grad school. So um, I knew I wanted to get a PhD, but it's important to think, okay, maybe a master's first to see if I really like more intensive classes and research. I'll talk about, maybe why a PhD isn't necessarily good for everybody. Um, doesn't mean that you're better than anyone or you're more qualified. It's a very distinct kind of career. You could still do a lot of wonderful things and similar things with a master's or bachelor's degree, but we could talk about that later. But So I went to UNC Charlotte. My undergrad advisor went to grad school, got his PhD with my grad advisor at UNC Charlotte, Dr. Eric Demel. So again, connections are important, putting in good words, showing yourself, networking, wanting to do a little bit extra than what class does. I had some internships during my undergrad too that were important for visibility and just experience. Work experience is important, not just what you learn in the classroom. You have to use it somehow. Um, so then during my master's, which was, I kind of did an accelerated program because I really wanted the PhD. So during my third semester of my master's, I got accepted into the PhD program. So I kind of finished my master's and took some PhD courses pretty early on. I had to take like, I think 18 credits one term with my thesis and new PhD courses. So yeah, it was intense, but I got it done somehow. My master's is in geographic information science and technology. So really getting involved with programming, mathematical, statistical modeling, where I applied it to my love for conservation as well, but this time terrestrial conservation. So um, since I went to school in New Hampshire for undergrad, I had experience using these data sets for my undergrad classes and final undergrad thesis as well, trying to understand how we could better protect environments that have a lot of biodiversity. New Hampshire has a lot of nice environments like that. So I developed this model with my advisor and another student to kind of optimize nature reserves based on the type of species and trying to separate certain parts of the nature reserve. So, if something catches on fire, it doesn't take the entire place down. Um, and then during that time, I wanted to get more money recognition, so I kind of just applied to all these different fellowships and got one of these fellowships that recognize, contributions in interdisciplinary research and statistics and geography and uh, computer science, stuff like that. And I was getting involved in health at this time too, because my PhD advisor, who was also my master's advisor, did a lot of work in Colombia on vector-borne disease. So vector-borne disease, Lyme disease, malaria, that he was looking at Zika, chikungunya, and dengue, which I'll talk about in the next slide. And I always wanted to travel for my dissertation, and that gave me the opportunity to go to Colombia, which I'll talk about. But everything's related to health when it comes down to it. So I always wanted to maybe consider med school or, my background in child psychiatry, kind of taking care of people. So I kind of used those skill sets that were very applicable to epidemiology, public health. So during my PhD, I specialized in spatial epidemiology, which I'll kind of go over what is epi and then spatial epi, more of the boring stuff in the coming slides. But for my dissertation, which is, it's like writing a book, you have three main studies and kind of an intro and conclusion tying it all together. You're contributing to the body of knowledge, or I'd like to think of it like a brick wall, and I'm putting a tiny brick in that wall of knowledge. And I studied, it was kind of a mixed method study. So I did statistical modeling, disease surveillance of dengue, chikungunya, and Zika, especially because chikungunya and Zika were pretty new to the region of Colombia during that time. If you remember the World Cup in 2016, Zika became a big issue, and there was worries about, traveling there and getting infected from the mosquitoes, children being born with tiny heads and all the complications with that. So, um, the mosquito that causes Zika also causes dengue and chikungunya. Dengue is endemic to Colombia as well as most parts of the tropical world. It's has the highest rate of cases, more than malaria. And there's four types of dengue fever that affect humans. So you could get dengue up to four times in your life. But we could talk about specifics later. But so I did, modeling dengue at the neighborhood level. So very tiny environments. Mosquitoes don't travel very far. Um, and you could go from neighborhood to neighborhood, and the situation could be much different in terms of those that are infected, those that might be dying, those that access care, and I'll talk about that more broadly soon. Um, But I took courses in epi and environmental health as well to kind of help me think through a lot of this. And I lived in Cali, Colombia for 5 weeks because I did a lot of interviews and surveys. So I surveyed patients and people at healthcare centers, as well as interviewing stakeholders like epidemiologists, the Secretary of Health, medical doctors, and trying to see if all those lived experiences and understanding of the disease and where they're doing surveillance and control kind of all lines up and linking that to my statistical model because data only tells you so much, the observed kind of stuff you see in maps and graphs, but there's a lot of stuff that's kind of unanswered by that you really need to hear it from the horse's mouth, as they say, right? So understanding people's experiences with the disease, what they know about the disease, how they prevent, um, or how to address risk factors by prevention, stuff like that, and what the kind of health system policies are doing. Um, so I'll talk about, why I'm interested in disparities and stuff like that shortly, but really fulfilling PhD. I mean, I had fun too. Uh, I was on the table tennis team for UNC Charlotte, so yeah, I played D1 table tennis, which is a fun fact. We almost went to nationals after losing to, I believe it was Duke in the regionals. They had the New Zealand national team on their roster, so it was a bit hard to beat them. And there was a former Olympian on another school that my colleague actually got a set on him, which was pretty fun. But yeah, so you're doing a lot of work, but it's still some of the best times of my life. Similar to undergrad and my master's as well. A lot of good friends that I still work with that they were in my wedding, stuff like that. And it also gave me a good opportunity to teach. So my PhD advisor and his wife both went on maternity and paternity leave, and I got to teach fundamentals of GIS and then medical geography, which we'll figure out what that is in a second. So I graduated in December of 2019, and well, really it started in September of 2019, where I presented at a conference in Edinburgh, Scotland, and Johns Hopkins was the only table there with the listing for postdoc. And it was perfect. It aligned with what I was doing. Um, I didn't know they had a spatial science for public health center. I applied for it. Luckily, I was accepted and started my postdoc in January of 2020. So if you, all of you were alive at the time,
What
COVID-19.
incredible timing.
Yeah, the pandemic
Wow.
started in March of 2020. So I came in to study Vibrio bacteria and oysters and kind of like water quality and foodborne illness using statistical modeling in the Chesapeake Bay. But I think I only have two papers from that. But COVID happened and I was stuck in my basement studio for a year and a half, pretty much doing nothing but research and trying to stay sane. And you might have seen, the famous COVID dashboard on the top right. Um, I used a lot of those data for my own research, and my team in the Spatial Science for Public Health Center, we collaborated with engineers and medical doctors to create this syndromic surveillance app. So people were sending us their symptoms every day, whether they were healthy or felt sick, their temperature. And we had hundreds of thousands of entries. And, you know, putting all our heads together, because team science is the best science, we were able to kind of predict or estimate clusters of confirmed COVID cases before they happen by looking at symptoms 5 days to 7 days in advance. Um, Published a lot on kind of doing good surveillance with COVID and why syndromic surveillance is important. Um, Looking at a variety of risk factors and don't have enough time to talk about all that, but I think I have 12 papers on COVID now. So it was great for my career, bad for my mental health. I think everyone's mental health went down the drain, but that really helped me secure a faculty job. So I joined faculty as an assistant research professor in 2022. Um, so I also have a joint appointment in the School of Medicine, and I'm an assistant professor of oncology as well. I'll get into that in a second. But in epidemiology, my primary appointment, I have three main kind of research areas. So, as you might have heard, methods development for disease and exposure surveillance, So a lot of statistics and trying to really get at granular levels of risk factors and outcomes at neighborhood levels across the life course. So not just these snapshots in time, but all these different periods of life that are really formative for your health and well-being. How does that influence, say, your risk of dementia or cancer risk and so on? Um, so that leads me to like my two main areas of expertise at the time. Like it was so hard to get funding in infectious disease with COVID. Everyone was applying, and as a spatial epidemiologist, I felt like my talents were can be used in other areas that didn't have as much kind of skill sets in spatial. Again, I'll talk about what that means in a few slides, but um, I have funding now in gun violence prevention, overdose surveillance, and substance use disorder. I've also published a bunch on suicide. And then in cancer epidemiology, I have expertise in colorectal cancer. Um, I work with the state health department on making sure people get screened for colorectal cancer, whether that's just the FIT test or Cologuard you might have seen on TV and following up with colonoscopies. I mean, even in Maryland, we still have some of the lowest rates of colorectal cancer compared to some other states, but some people have to wait a year for colonoscopy. 60% of our cases are late stage of diagnosis, and no one should die of colorectal cancer. Colonoscopy should catch it early. You clip out the polyps and cancerous lesions and hopefully get it before it turns into metastatic cancer, right, and invading other organs. I also do a lot of work in breast and gynecologic cancers like ovarian, endometrial, cervical, and so on. And so, with my skill sets in spatial epidemiology and kind of disease surveillance and working with the state health department on some early projects, I was invited to join the School of Medicine in oncology. And as of July of last year, lead the data science team, really working with community advisory groups. So, we have 4 regions in Maryland that we work with, um, providing them with analyses tailored to what's going on in their communities. Every community, every part of Maryland and up the country have different risk factors and barriers to care for cancer. So we try to build capacity with them and help with some like on the ground education or data analyses, implementation science. Like I'm working with a gastroenterologist in the Eastern Shore of Maryland, very rural, to understand why people are waiting a year for a colonoscopy and kind of what providers are recommending and how we could make this more efficient and more timely, recognizing symptoms. But also, with that, I have access to like all these other cancer data sets too. So if they say what's going on with lung cancer and people that don't smoke, things like air pollution and radon, stuff like that, I could provide some analyses, not just me with my team, but um, and with that, I'm on the community outreach and engagement and cancer prevention and control steering committees, which allows me to work with, our medical director and all the higher ups to kind of figure out how to best serve the state of Maryland and Hopkins, our cancer center. So just kind of summarizing what I've been doing, I don't really like, highlighting myself, but this is important. This is part of what I do, and this is team science. It's not just me that all these statistics show. It's a lot of students, it's a lot of mentors and junior faculty like myself working hard to produce good science and get funding. So currently I have 56 published papers and 2 book chapters, bunch of presentations, invited talks. Most enjoyable part of my job is, I'm a research professor. I mean, everyone at Hopkins pretty much, we're a research heavy institution, but teaching is important. We're not number one in epi and public health for no reason. We, try to train the next generation of good scientists. So I enjoy working with PhD and master students. Just graduated my second PhD student last month in cancer, which was fantastic and, really reflects on Catherine's ability. And she got a postdoc at UCLA now. And my first PhD students at Tufts in Boston working on overdose stuff. So um, Bloomberg School of Public Health, where I'm working in the School of Medicine. It's all graduate school, right? The undergrad campus at Hopkins is Homewood campus, which is kind of West Baltimore, Northwest Baltimore. Um, so I don't get to interact with m many undergrads, but some have do the joint program in bachelor's and master's. Um, and I also teach, all the spatial analysis courses along with some of my colleagues in the Spatial Science for Public Health Center. Um, the research funding is, it's not just me. That's, one project was like 15, $16 million that pays like, 100 people. So either leading or being a co-investigator on these grants, we get money from the federal government, from state governments, internally with GHU stuff, whether it's philanthropy or, through our endowment and kind of funds given from other kind of sources. There's different kind of organizations, American Cancer Society, all these other things that provide funding to do good work. Um, so just kind of wrapping up with some slides here, maybe another 10 minutes or so or less. Dan asked me to kind of describe very briefly what is epidemiology, right? So coming from this book, The Dictionary of Epi, which we teach in Epi Methods at Hopkins, it's the study of the occurrence and distribution of health-related events, states, and processes in specified populations. So this is descriptive epidemiology, and then it gets into the analytical piece, which is including the study of determinants influencing such processes and the application of this knowledge to control relevant health problems. So it's really just understanding diseases, their spread, and what causes them, and kind of how to either treat them or cure them. Um, an example, very relevant and recent, the measles cases that we're seeing again in the US. We're about to lose our measles eradication status. As you can see, very flat for many decades. And then, 2018, 2019, seeing these massive spikes.
I'd like to see if any students can guess why this is happening. Why are we seeing this trend here?
I have the answer on the next slide, so that's actually a good question.
Dylan.
My guess is that people just stopped getting the vaccine because it was kind of terminated.
Ding,
And
ding, ding. Yeah, it's quite simple, actually. Vaccines are fantastic, probably the best gift we've ever received besides plumbing. Um, so yeah, so on our measles tracker here that you could play around with later, you could see these kind of hotspots of measles cases, whether most of them are local, some are imported, um, either from out of state or from travel, which is more rare. But as you can see here, percentage of reported measles cases by vaccine status, 94% of measles cases that are now reported in this country are unvaccinated. 6% are vaccinated, which aligns with what we know from vaccines, that they're 97% fully protective for life of measles if you get the two-dose regimen when you're a child. 3% are a bit unlucky and don't have full coverage or full protection, so you could still get it, but it's so rare. And even if you're not vaccinated, if enough of the population gets a vaccine, that protects people that are not vaccinated. This is called herd immunity. It's quite simple, and could wish I could teach more about this today, but yeah, you have good teachers there at Holy Cross. So, and this is unfortunate, and the areas that had the highest mortality rates, and incidence rates and complications with COVID were those that did not get the vaccine or kept up with their boosters. So can confirm vaccines work. Um, and so what is a population? What is EPI concerned about? It's really about these three constructs: person, place, and time to make up our population. So a person, obviously you, me, you have an age, a sex, a race, ethnicity, jobs, places. That's where I come in later. Country, state, city, place of employment, and then time. Time in the life course. Stuff in your childhood could come back to haunt you when you're an older adult. So every decision you make now, every exposure could impact your health and well-being down the line. And so what I do is I take this concept of place and make it a bit more complicated. So, medical geography, spatial epi is really looking at the spatial distribution of things and why the environment is really important to understanding why it might amplify our risk or reduce our risk. Your neighborhood, your county, your city, all these different things, you have shared experiences and risk factors as your neighbors and people you interact with. I'll get into a little bit that in a second. Um, so we use GIS. Speed up a little bit because I noticed the time. Geographic information systems. So really just getting anything with spatial data. So like making maps and seeing patterns, and then we go beyond the map, as we like to call it, and use spatial statistics to see if those patterns are meaningful or they're just it's random noise and not really important for risk factors or causing the disease and whatnot. Um, so I'm not going to go over this graph in too much detail, but this is really highlighting the nexus between health and place is what I'm really interested in. So, think about your daily activity spaces, your neighborhood, doing errands, going to school, going home, where you recreate. You go somewhere for the summer, you change your residence, you might move to another country, change jobs. Just think how this influences, your health and well-being and how it influences the spread of disease. Um, and why are location data so important for public health? So this is where geography really comes into play and the power of spatial. So there's actually a law in geography, and it says everything is related to everything else, but near things are more related than distant things. And it's I had an asterisk to this because it's not just proximity. Think about social networks, transportation, social networks. I might not interact with neighborhoods that are right next to me because they don't have things that I'm interested in. So I might travel a little bit further, and those areas might have more impact on my health and well-being than things that are closer to me in proximity. So we account for that as well. So it's this whole idea of spatially dependent phenomena. At least we could test for that. Are things actually more related than things far away? And yeah, more often than not, it's the case. People have shared experiences and, communities. It's kind of the definition of a community, right? And culture. Um, Spatial dependence and clustering in data, public health data could be due to contagious agent, right? It starts in a small place and then spreads out to other counties and cities. When we think about like infectious disease, people might not have the same resources as you and I, so they might not have the means to get good health care or travel to get cancer screenings. Maybe they're worried about putting food on the table or they live in a dangerous environment, so they're probably not thinking of all these things to protect themselves. Um, this is just one of the studies I did on COVID, kind of tracking this excess clustering of cases over space and time during the early pandemic. And I'm really interested in social determinants of health in neighborhoods. I like to use Baltimore as an example because you could cross an imaginary boundary or a neighborhood and your life expectancy could go down by 10 years, right? The average life expectancy for Black men in Baltimore is in the mid 60s, which is unacceptable. And there's a really famous book by Dr. Lawrence Brown called The Black Butterfly, which is what you see here in West and East Baltimore, that just have such extreme excess mortality and barriers to care. Um, but another point I want to make is that, neighborhoods are very important to our health. Is it walkable? Can you get food in a decent distance? And is that food healthy? Or is it just corner stores? Think about safety and can you go to a park? Quality education, pollutants, noise, all these other things that are important, things that you might not really consider that might influence kind of your anxiety levels or how you're getting sick, stuff like that. Um, so finally, why should we care about place-based determinants of health? You know, you could go to the doctor and they could tell you exercise, eat right, get more sleep, interact with green space, all this other stuff. But maybe you live in a desert and those opportunities aren't there. I work with medical doctors quite often on projects, and they ask me, why are people coming into the hospital? Why is there someone coming in 300 times in 5 years for overdose complications, which is true with one of these cases? Why do people keep coming in for various reasons. And, it's the social determinants of health and all these risk factors that belong to where they live, work, play, and stuff like that. So just I could send the slides later so you could digest them a bit more, but I'm really focused on, influencing people's behaviors, but more importantly, the built environment and the systems in place that might reduce their health and well-being across the life course. So things like social community, economic stability, healthcare access, education, stuff like that. Um, just some examples. I was the editor on this paper in a journal called Health and Place. My buddy Matt Hobbs. I didn't. It was blinded, so I couldn't see who submitted it. But I was like, "Oh, it's Matt. It's your paper. Very good." So he had all these papers, or sorry, all this data of participants in New Zealand, tracking them throughout their life, and he showed that you know children that moved from high to low socioeconomic status neighborhoods increased their depression risk by age 16. And there's a decreased risk in anxiety disorders in adulthood in stable middle class or increasing income trajectories in early to middle life. Some work we've done on suicide, looking at suicide hotline calls and hospitalization data, self-injury and suicide, kind of looking at where in North Carolina there is excess relative risk. Um, Finding that, micropolitan areas, these smaller cities, towns, had higher risk suicide clusters, 2.5 times more likely in low-income areas. Even though we had 25 samples of Native Americans, they're 14 times more likely. Military personnel, 1.86 more times likely to commit suicide, and high risk for self-harm, white, Medicaid, self-pay insurance, all these other risk factors. And the kind of public health officials in North Carolina use this to help with some of their um, education and kind of targeted interventions.
Native
Um,
Americans are one of the most at-risk groups for a lot of things, right?
yeah, so we don't have many in Maryland, but I had a project in Wisconsin looking at methadone access for those that use substances,
Mhm.
opioids. And, Native Americans have some of the highest rates of smoking, colorectal cancer, actually,
Yeah.
alcoholism, deprivation, deaths of despair, as we call it. So, um, sorry, this took longer than I imagined. So, anyways, yeah. So my current work is really looking at colonoscopy and colorectal cancer outcomes. So, I kind of found where colonoscopy providers were in the state and those that could be reached outside within 30 miles because you could go out of state to get a colonoscopy if it's in network. Um, and you can see here, not a lot of providers in the Western Maryland, Eastern Shore regions. Just quickly showing like, mapping risk and areas with high and low access. You could look at this later. Found that neighborhood level social vulnerability is strongly associated with late stage colorectal cancer. So we found it's more likely to be kind of socioeconomic disadvantage and barriers to care and screening rather than proximity. Black populations in Baltimore have the best access, potential access in terms of just looking out the window and what's available to healthcare and doctors and whatnot, but they still have some of the worst outcomes. And there's a lot of factors to that, like the non-spatial barriers, like health literacy, cost, trust in the healthcare system, but also some social determinants of health, which are, of course, place-based, which I covered. Um, so I want to leave some time for Q&A. So thanks for listening for now.
Get a little applause for Dr. Desjardins for our excellent informative talk. I'm sure you guys all have some questions you'd love to ask.
Cadence.
You said that you did a lot of work during COVID, but like I know the circumstances during COVID were like weird. So how did you like go about doing that work?
Yeah, so, I was in my office one day. I was ready to go to my first adult soccer game, excited to meet people, and then it was canceled. We had to go home and quarantine. So during that year and a half when we were all in quarantine, Zoom became a thing. So all of our collaborations were on Zoom. So it was a lot of time in front of a screen. The medical providers still had to go in person with all the protective equipment, so they were able to do their job, provide us data and whatnot. So I think, we re really didn't know what to do. Like we had to completely change our classes, like just like that, changing the way we deliver lectures and do assignments, and I think it worked out fairly well. We still have a lot of hybrid courses where some students prefer to stay home or they're remote learners. I prefer to be in person, but that's just the way it is now. But I mean, I'm not a medical doctor, so I could do all my work behind the computer. So I just needed the data and talking to people, and it was possible to pump out the amount of research that I did because of that. But it was hard to take care of yourself when you had to stay home the entire time. So that was a bit frustrating. And I didn't really know anyone in Baltimore. So didn't want to go home to see family because, everyone was getting COVID. So it was just, I'm sure, as you know, a rough time for everyone. Asia.
Do you think AI will take over your job in the future?
Good question. I actually just I was invited to talk in a panel in Toronto in July about the future of quantitative geography in the era of AI. And there's some nice papers that have came out recently just talking about it's a tool. It doesn't replace critical thinking. It doesn't replace science. Whatever you feed into the AI model or whatever you ask it, humans made that, right? So AI does not understand disease transmission. It doesn't understand relevant factors that are related to the disease. So even if you have a model that perfectly predicts something, those variables could just be in place for something else. Like a good example I like to give is you could look at alcohol outlets in violence and have a strong positive association that, areas where there's a lot of alcohol access, you might have more violent crimes or assaults. But if you replace that with churches, you might get the same exact association that just because that's where the population is, that's where the people are. So you have to be really careful on what you put in the model. So theory is really important. So if you don't understand the textbook stuff and how things work, you're just going to get garbage out. So, no, I don't think it's going to replace my job. It's only going to make us a bit more efficient with coding and computation and kind of synthesizing stuff I don't have time for anymore. Like, uh, you know, here's this nice paper, show me the highlights, and then I could read a bit deeper into it once it shows me where to look. Maggie.
What would you say that the hardest part of your job is?
So I think it's good to highlight that at Hopkins, unlike some universities, I think so when I started, only 10% of my salary was paid for by the school. The rest were grants. So you constantly have to write grants to fund my salary. They set my salary, and then I have to find money to pay for it. So as you're working on research you're funded for, you also have to submit grants to fund your salary for the next couple years. And with the funding cuts the last few years with the current administration, we really had to scramble to, you know, find money to make sure we don't lose staff and faculty. And other universities, 100% of your salary is guaranteed by the school, and you could get grant money to supplement your salary. But here, um, currently, I get, I think like 35% is paid for by the school because of my cancer center appointment. So I think that's the hardest part is just, it's not a 9 to 5 job. You're constantly thinking about it, which could be frustrating at times, but that's how just science works and how you got to get grants is just constantly have ideas in your head. Yeah, I compartmentalize that, but it's a hustle for sure. It's a grind to constantly thinking what's next. I think I saw Madeline next.
Hi. Does your work change how you think about disease risk in everyday or public spaces?
In terms of, am I freaked out when I go out into crowded spaces and whatnot?
Yeah.
Yeah, I mean, we had a test every few weeks to be on campus during the pandemic when it was at its peak. And at this point, it's the same as before. Enough people thankfully got vaccinated, and I got all my boosters, and I take the necessary precautions. I exercise, and um, you're still going to get sick. So I don't wear a mask as much in like crowded places. I still try to when I'm on a plane and trains. But yeah, I think more about, kind of pollution and lead. There's still a lot of lead pipes in Baltimore that we're trying to address to make sure kids don't have any neurological disorders later in life. So I think that's going to benefit my kids just being more aware of things. And especially lung cancer rates have gone down a lot because people stop smoking, but obviously with vaping and stuff, but still not as dangerous as cigarettes. Not saying you should do any sort of smoking. Anything's bad for your lungs, but there's still early onset lung cancers and certain increases in certain areas because of the pollution. So thinking about air quality and climate change, all these things that are all interrelated. Um, it could get overwhelming and complex, but yeah, I think I'm just more kind of aware of when I look outside and go throughout my day, kind of preaching what I'm, or practicing what I'm preaching, that yeah, everything that I see and do is influencing my health in some way. Dylan, or sorry, Andrew was next. Sorry, I don't know who was in line. You guys could.
Dylan's next. Dylan's next.
You've done a lot of research during your career, and we're going to be researching and publishing a paper our senior year. So, do you have any tips for like going about doing research and writing papers?
That's an awesome opportunity. I wish I had that in high school. Yeah, so, you know, simple is often better. I don't like papers that like to flex the mathematics and statistics. And it's like, what's the point? What are you trying to solve here? Are you just solving the problem or addressing the problem, getting to the same conclusion with just a more fancy method? In terms of like the writing process, I like to think of it like a funnel. So you start with your introduction. What is the general area that you're working on? Kind of some gaps, what's not being done or what do we not know enough about? Where are you trying to kind of fill? And then the last part of the introduction includes like, okay, this is we are going to use hair samples to understand lifelong heavy metal contamination and how that links to prostate cancer, something like that. And then, you know, describe your methods clear enough that the layperson could understand it. Audience is important. Don't assume that everyone knows what you're talking about. And then results is just stating the facts, right? You just, this is what I found. And then the discussion is really where a lot of important things happens. You want to elaborate on your key findings. Was anything surprising? What are some opportunities for future research? Because obviously you can't do your life's work in one paper. And what limitations are there? Is it data limitations, sampling limitations, unexpected results? And then, at least in public health, what's the public health implications? Are you actually informing policy or a public health problem that can be beneficial to populations and people? Or are you just trying to get citations on Google Scholar? So I think linking it back to the overall like policy and how is it going to benefit humanity is important and not just doing a method just to show that you know what you're doing in terms of math. It's not so fun. So yeah, just being very clear in your story, making sure that everyone understands it, even your grandmother, right? So, Andrew.
So what role did spatial epidemiology play in like COVID that we might, not realize yet, and like how was it important to the findings of COVID?
Yeah, I mean, it's a really important question, and we didn't really know a lot about COVID in the beginning, so we're all kind of just learning risk factors and how the disease was being spread. You know, what's the potential for everyone in the neighborhood to get it, and how quickly is it going to happen? But I think with spatial epidemiology, we were able to see, okay, where are people getting vaccinated? And if enough of that population gets vaccinated, is that going to protect that kind of county or that city due to herd immunity? But also like the health disparities piece. So, there's a lot of workers that had to still go to work, um, these restaurant workers, the healthcare workers. So kind of understanding their activity spaces and where people lived and the number of people that might live there. People might live in a home with like 10 other people, right? In apartment buildings. So all these different things in the environment and space, right? For the spatial epi piece is important to kind of understand the potential for this disease to spread. And, how many vaccines do we need? How many tests? All these different things to estimate when we could curb transmission at a reasonable level. And some of my other work, and not just me, plenty of cooler people, Nobel laureates at Hopkins and other universities have done a lot of more impressive work probably on thankfully stopping. I mean, just the speed at the vaccine that came out. We had the technology before, but it's such a relief to get that within the first year, right? So there's a lot of spatial epi going on with that. A lot of health departments have people like myself to understand who's at risk, where, when, and the whys, right? So 70% of all questions, I think I heard a quote somewhere, involve a where. So just think about when you ask questions, place probably comes up a lot. Marcella.
You hear me?
Yeah.
Um, a little bit of a different question. How did you like know that you want to go to grad school? Did you enjoy it?
Yeah, I think um I don't know, I just love science and you can only do so much in 4 years as an undergrad and you really get more of that exposure and research opportunities in graduate school because you'll be working in a lab. You have to more often than not write a thesis, and then obviously PhD, you have to write a dissertation and contribute to the body of knowledge by producing original science. So I I'm just really curious. I like to just I was always on Wikipedia as a kid or other websites like, you know, what is this disease? Like, why is this culture different in this region? I was always interested in like languages and flags and why certain populations in the world didn't have the same quality of life as me, and I wanted to really study that, and I think that's where the kind of geography piece comes in. Um, and it's important to have good mentors. Yeah, I've heard bad stories too, but I've had people that treated me as a person and as a scientist contributing to their own work, not just a robot in their lab. And making friends early on, you're suffering together, you're accomplishing things together, you're doing science together. I would go out on the weekends and play sports with my friends. We would essentially spend our entire lives together because we'd have to find cheap housing. So it was almost like college all over again, kind of growing up. And obviously, you're more professional in grad school, but your well-being should come first too, right? So it's not just about the science. It's um, taking the time to enjoy your life outside of the work and I had opportunities to do both of that. But yeah, I think the most important thing is just finding like a mentor that will really value you and your well-being and um, not treat you like a robot, like I said. So some labs are like that, but interview your potential PI and mentor before you go to the school. Don't just go there because they have a name. They could not necessarily be the best kind of person to work with.
I totally agree with that. Uh, I knew a lot of PhD students who went to grad school for the wrong reason, and they were not good grad students and they were not good scientists, and it didn't work out very well for them. So you kind of have to be passionate, find the right mentor. Um, I am throughout your presentation, I could see Gambardella, his influence on it. Did he make you guys do? I think about so how many hit your raise hand if you had Mr. Gambardella at some point.
One,
Lily,
two.
yeah, I thought there were a few more. There's a few who are at theater, I think, who went there because he's at it's now called Holy Disciples, but it um St. John's. It was St. John's in Watertown. That's where he is now.
I didn't
Um,
know that.
yeah, he. So when you were at St. Pete's, who was the principal, Mrs. Curry?
That's right. She's
Yeah,
unfortunately not with us anymore, but yeah.
yeah. Her. So she's one of my moms. Her, my best friend is her daughter.
Mhm.
And did he make you do all of the maps with the sharp pencil and
That's right.
yeah?
Yeah. So that's when I was like, okay, I'm drawing these countries, capitals, but I would always go online, make my parents buy me a globe and figure out who's
Hmm.
there, what's going on,
Hmm.
why are
Hmm.
these people uh, have less opportunity than me and all this stuff. And maps are, you know, a small part of what I do, but are really powerful. Like the decision makers, the policy makers, the patients,
Yeah,
whoever it is, it tells a story. They could all understand a map where they live, work, and play, and how that, it's like, oh yeah, that makes sense, rather than just looking at scatter plots or bar graphs, right? So
yeah, yeah. Did he ever tell you? I'm posing this question because I actually tell my students here about this, but did he ever tell you about his master's thesis?
I know he got a master's in geography at University of Vermont, but I don't know what his thesis was about.
So when this is mostly freshmen and sophomores because we just started the program. And one of the first things I do in my honors biology class when they first get there as freshmen is I have them get comfortable with debating. So you pick a topic that's controversial or whatever. And one of the things that instigated that was the topic of his thesis, his master's thesis. His thesis was that no war was ever fought over religion.
That's fascinating. I might
And
disagree, but I'd like to read it.
right, everybody's knee-jerk reaction when they hear it is that no way, right? Like
Hmm.
that's no way. And I don't know if, and I hope I'm not like misrepresenting his thesis because I think about it all the time that he had this thesis. I don't know if he actually thinks that. But one of the points of like having a thesis is you're going to defend it.
That's right.
And his defense of it when I talk to him about it is fascinating. Like he actually can show that almost every war was not fought over religion. Like anytime I challenge it, I would challenge him on it. He'd be like, "Nope, here's why." Blah, 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 blah,
It's
blah.
fought over
And
land, right? Most
yeah,
of the
you
time.
Yeah.
land resources, stuff like that. And but like one of the things I use that as an example that I want my students to take home is make argue your point, right? Like have a thesis and defend the thesis. Don't waffle. So you were talking about how to write a paper and what are the funnel and the most important parts of the paper. The freshmen right now are working on their very first lab report that's done in manuscript style, and it is due tomorrow. And they're all kind of freaking out about that because they're having a very hard time. Writing is not taught the way it was when we were younger.
Yeah.
So
Okay.
it's and I don't. If you're not teaching undergrads, you're probably not seeing much of the results yet. It's coming, but
I saw a
the
little bit of that with some of my master students, but I don't know if that's a COVID effect or not.
yeah,
But yeah, just science writing is obviously different than creative writing, and there's different techniques. And
yeah,
yeah, you know, it's still a challenge for all, even senior faculty. Like you want to translate your science to the layperson and the people we want to help, and
mhm,
you're going to talk differently than talking to people that are experts in the room, right? So,
mhm,
and that's, it's important because when you're submitting papers to journals, you're going to have these peer reviewers you're never going to meet that you have to convince them that this is good science. And, you'll deal with rejections, you'll submit it to another journal, and maybe there's a better fit. It might not just be that it's bad work, just got to find the right home. And that's the same with like writing. You got to, who is your target audience and make sure they understand it.
mhm.
Have you seen those like reviewer two memes?
Oh, I dealt with that a couple months ago with the breast cancer paper with one of my students. The person said, just because there's a disparity doesn't mean we have to address it. I'm like, what are you talking about? And so we had a fight with the editor, like, no, this, like, we're done. Like, this is the only comment. Like, what do we have to
I
convince
so
you
I
for?
just for the students' sake, I get when you submit to peer review, there's was it usually two or three reviewers that have to
At
review?
least two, more often
Mm.
than not, in like the really top journals. Three at least. I've had six or
Yeah.
seven sometimes, depending on how
Wow.
specialized it is. Like you need a person that is expert in this method or this body part, whatever.
And I guess it's kind of a joke in the community of researchers that like the first reviewer is usually like pretty nice and easy, and the second reviewer just tears your paper to shreds for the littlest details.
Yeah, the first reviewer is probably the one that said yes first and was like, "Oh yeah, I can't wait to review this." And then the second reviewer, you're nagging to get on the paper to review it because you need at least two to evaluate it. But yeah, so you'll encounter that people that don't know what they're talking about are just contrary for the sake of being contrary, but it's your job to defend it and, find champions for your work.
Well, I think we could wrap it up. Thank you very much for speaking to us. That was pretty cool, and gives them a taste of something they've probably not thought about before. I mean, so wait, how you guys were in second, third grade or something when COVID was happening? Is that right? Third
Third.
grade, yeah.
Wow.
Third
Do you
grade.
guys remember the maps coming out of Johns Hopkins with all the infections? I had it on in a corner of my screen at all times. Like it
Yeah,
was, yeah.
it was in the White House in the Situation Room, and there could have been better analytics, and
Hmm.
it was just kind of graduated circles and colors. So,
Hmm.
anyways, yeah, we're known for that, and it was just like a postdoc saying, "I want to help my family in China and Shandong," and Lauren Gardner, the engineer, said, "Hey, let's expand this to the entire world," and that's what they did. And yeah,
Hmm.
probably the most famous example of maps for
Hmm.
disease.
Hmm. Yeah, very cool. Well, thank you very much. So, well,
Yeah, it was
okay.
great to talk to all of you, and
All right.
Dan could give you my contact, or I could send you my slides. I'm always happy to talk offline as well. It's
Cool.
important to influence the next generation, right? And
Hmm.
um, yeah, you're in good hands, it seems, and a little emotional talking about Mr. Gambardella and St. Pete's. It was just like, yeah, it's a big part of
Yeah.
my life. So yeah, thanks
Yeah.
for
Yeah.
bringing that up.
All right.
It looks like we
Uh,
do have one last question.
Sure,
Josh,
Joshua, sure.
Um, I just wanted to ask, like, how many more years do you think it's going to take to be able to see the side effects of the COVID vaccine?
It's a good question. I think we know more than enough now with the event reporting system. With any vaccine, there's going to be side effects, but the point is you're making it safe enough that it's so rare that the benefits outweigh the minor risk. Um, we would have saw a lot more deaths and hospitalizations. I promise there's no conspiracy. And, my wife right next to me is a biochemist at a vaccine company, and she's not doing anything sketchy, but it takes a long time for vaccines to come out. It takes, I think, 10 years at least for a drug to be able to go on market, if not longer. So the technology was there. They were just able to quickly isolate the COVID virus and figure out how to obviously protect people. So um, all the other ingredients in there are so like minor that it doesn't really impact your body if there's any mercury, stuff like that. And vaccines have been around for a very long time. And I think we would have seen a lot more issues in our populations when what's really killing us and making us less healthy is the pollution, the PFAS or forever chemicals, as we call them. There's still a lot of lead in the environment. Radon, which is colorless and odorless, that might be in your house. Hopefully, your family has a detector, but not really a problem in Connecticut. So, yeah, there's always a risk with anything you put in your body, but it's the greatest gift we ever received. So, it's a good question, and happy to follow up more on kind of some of the formal studies with it.
I'm glad the students have a chance to talk to you, Mike, about this because I think education is one of the best tools when it comes to those fears, which a lot of people they fear something like a vaccine because they don't understand how it works. They don't know what's in it. So, I think the more educated people become on the topic, the less fears you're going to have usually. But of
Yeah,
course, make sure
invite
you're
my wife next
using,
time.
what was that? Invite your, oh,
She's
Brianna.
the
Yeah.
she's the vaccine expert, right? So,
Hi, Brianna.
oh, one last thing I like to do. I saw some cats, so I want to just pay my pet tax and show you my dog quick. So my German Shepherd Otto keeps me sane and is my best research assistant. So he's a little
They
tired
say hi, Otto.
from the heat today. So, but yeah, like I said, I'm always happy to talk to students on the site. And if you ever want to do this again informally, I'm happy to hop on another call. It's my pleasure. So it's great to see all of you. Of
Cool. Thank you.
Thank you so much for your time, Mike.
Thanks.
This has been
course.
awesome.
Thanks, everyone.
All
Have a
right.
good night.
All
Thanks,
right, guys.
everybody.
Good luck with your studies.
Yeah, good luck, everyone. Stay curious.